Hello my dear students, in this video now we are going to discuss about the what is Acyloin condensation and what is its mechanism. In Acyloin condensation, Acyloin is the main product. Okay na? So when ester general formula is RCOR. Okay na? So for convenience we put it as the R dash. So when these esters are refluxed with sodium metal in the presence of the aprotic solvents like benzene or toluene or xylene. So we can use any of these aprotic solvents. They give the Acyloin. Acyloin means alpha hydroxy ketones. Again, alpha hydroxy carbonyl compounds are known as the Acyloin. So this is Acyloin. Here it is the ester. So in Acyloin condensation, we get the Acyloin from the ester. Acyloin means alpha hydroxy carbonyl compound. Now we go for the mechanism. Actual mechanism is not yet established, but a radical mechanism is proposed for this one. Sodium metal gives its electron to the ester. As a result, we get the intermediate in which carbon exists as the radical and oxygen exists as the anion. So look here. O minus OR. So here sodium metal. So here this is the first step. In this step, carbon free radical is generated. Now in the next step, what happens means two such species. We can name it as the intermediate one. So in the second step, intermediate two intermediate molecules combine and form the intermediate 2. So now we get the dimer of the intermediate 1. Dimer of the intermediate 1. In the next step, what happens means these dimers lose alkoxide molecules. So look here, this electron pair shifts here. So these alkoxide ions goes outside. As a result, we get the diketones. So we get the 1,2 dicarbonyl compounds. In the next step, is 1,2 dicarbonyl compounds react with sodium metal atoms and form sodium salt of indiol. So this is the sodium salt of indiol. Indiol. When sodium salts of indiols are treated with the acids, protic solvents, like acetic acid, we get the enol, indiols. So this is indiol. In the next step, this indiol undergoes tautomerism and we get the acyloin. So uh, okay, now sorry, this now this electron pair shifts here. As a result, what happens with so we get the acyloin. So like this we get the acyloins. Now we go for the main application of this Acyloin condensation. By using the Acyloin condensation, we can prepare the cycloalkanes. So it is mainly used to prepare the cycloalkanes. So to prepare the cycloalkanes, we take the diesters. So look here, like this, we take the diester, and on treating with the sodium and refluxing with the sodium in the presence of protic solvents, we get the cyclic acyloin. Okay, this on reduction gives the cycloalkanes. So this is the main application of the Acyloin condensation.